It's kind of crazy how fast these large language models are changing.
It really is.
It feels like every other week there's some crazy new thing happening.
Yeah.
And recently there's been this like buzz around post-training techniques.
Mm.
It seems like everyone's really focused on making these huge models like reason better,
Uh-huh.
but without needing a ton more computing power.
Right.
So it's like, how can we squeeze even more smarts out of what we already have?
Yeah, that's the big challenge right now.
Exactly.
It's like efficiency is king now.
Yeah.
We've got these massive models.
Right.
But, just throwing more compute at it isn't always the best answer.
Yeah, you can't brute force everything.
Exactly.
So finding these like clever ways to get more intelligence out of the models we already have.
That's the real key.
That's super exciting.
And it really suggests like we might be closer to AGI
yeah.
than, just building bigger and bigger models.
Right.
It's more about like being clever with the training and the techniques.
Yeah, using what we got.
Exactly.
So this leads perfectly into what you sent over to us,
Yeah.
this DeepSeek AI research. So we're going deep on their DeepSeek-R1.pdf paper,
Okay.
which really focuses on this interesting angle of using reinforcement learning, or RL, to improve LLM reasoning.
Right.
So again, back to that idea of post-training,
Mm.
taking these existing models and making them even smarter without these huge computational costs.
Mm-hmm.
And I think what's really cool about DeepSeek AI's approach,
Yeah.
especially with R10, is it's such a direct way of tackling that.
Exactly. And what's fascinating to me here is that they're really focused on seeing if reasoning can emerge more organically
Okay.
through, carefully designed rewards,
Yeah.
rather than relying on all this pre-existing human-generated reasoning data.
Right.
It's kind of like, teaching a child through experience rather than just giving them a textbook and saying, memorize this.
Interesting analogy.
Yeah, I think it's a good way to think about it.
Yeah. So it's like letting the model kind of discover those reasoning paths on its own
Exactly.
through trial and error and feedback.
Yeah, and that's a very different approach than a lot of the other work that's been done,
Right.
where, you have to collect these massive data sets of human reasoning,
Yeah.
and then you fine-tune your model on that.
Right.
This is like, let's just see what happens when we give the model the right incentives.
And see what it comes up with.
Exactly.
Now, the paper introduces two main models, right?
Yes.
DeepSeek-R10 and DeepSeek-R1.
Uh-huh.
What's the core difference there?
So think of DeepSeek-R10 as the more radical experiment.
Okay.
It was trained pretty much purely with reinforcement learning,
Okay.
directly applied to their base language model, DeepSeek v3 base.
So just straight RL.
Straight RL on this base model.
Okay.
Now, DeepSeek-R1, on the other hand,
Yeah.
it gets a little bit of a head start.
Okay.
It's given some initial high-quality data
Okay.
before the reinforcement learning kicks in.
So a little bit of supervised learning sprinkled in there.
A little bit of supervised learning to kind of guide it along.
Interesting.
Yeah.
Now, here's where I thought things got really interesting.
Yeah.
The paper talks about this really surprising finding with DeepSeek-R10.
Mm-hmm.
It sounds like it was actually able to do some pretty impressive things with just RL.
Yeah. The researchers were actually quite surprised
Okay.
to see that DeepSeek-R10 developed what they called remarkable reasoning capabilities.
Yeah.
And these really powerful and intriguing reasoning behaviors seemingly out of nowhere,
Out of nowhere.
with no supervised fine-tuning.
Yeah, that's what's so mind-blowing about it.
It is.
It's like this complex reasoning just emerged
Yeah.
through the right kind of like reinforcement signals.
Yeah, just by giving it the right incentives and letting it explore.
It's amazing.
And I think that's one of the big takeaways from this paper.
Yeah, our mission today is to really unpack how they did this and what it all means, especially for how we think about AI developing reasoning skills.
Mhm.
I was thinking like the real Blinkist version of this is that sophisticated reasoning may not always need tons and tons of human data,
Yeah,
as long as you have the right kind of learning process.
exactly. And that's a really big shift
Yeah,
in how we think about developing AI.
it's a whole new way of thinking about it.
It is.
So let's dive into that.
Okay.
Let's start with DeepSeek-R10.
All right.
They were talking about directly applying reinforcement learning to the base language model.
Mm-hmm.
What was the core idea there?
So the question they were trying to answer was, can we get reasoning to emerge
Okay.
just by giving the model rewards for correct answers
Interesting.
without actually showing it how to reason step by step,
Okay.
in advance?
So it's like throwing it in the deep end and seeing if it can swim.
Yeah, pretty much.
And what kind of reinforcement learning algorithm did they use?
They use something called GRPO.
Yeah.
GRPO, Group Relative Policy Optimization.
Okay.
And GRPO is really interesting because it's very efficient. A lot of RL algorithms require this separate critic model
Okay.
to evaluate how good the policy is.
Yeah.
GRPO doesn't need that.
Okay.
It estimates baselines directly from the scores of a group of generated outputs.
So it's like comparing different attempts that the model makes and then seeing which ones are relatively better within that group.
Yeah, exactly.
So you don't need this extra critic model kind of judging everything separately.
Right. You're just comparing within the group.
Smart.
And that saves a lot of computation.
So more efficient.
Yeah, much more efficient.
And the objective function, which they show in equation 1 in the paper,
Yeah.
it focuses on like maximizing the probability of actions that do well compared to the group. But also it tries to make sure that the new policy doesn't stray too far from the old policy.
Right. So it's like a balance between exploring new things and not completely forgetting what it's already learned.
Got it.
And the advantage calculation in equation 3.
Okay.
That basically normalizes the reward for an action based on how well the other actions in the group did.
Okay.
So, if everybody in the group did poorly
Yeah.
and one action did slightly better,
Yeah.
that's still a significant advantage.
Okay.
Whereas everybody in the group did really well,
Yeah.
then only a truly exceptional action is going to stand out.
Right. It's all relative.
Exactly.
It's like grading on a curve or something.
Yeah, exactly.
So they've got this efficient way for the model to learn.
Mm-hmm.
But what about the rewards themselves?
Yeah.
Like, how did they actually tell DeepSeek-R1 what was good reasoning?
So this is a really important point.
Okay.
They kept the reward system for DeepSeek-R1 very simple.
Okay.
It was mostly just accuracy rewards and format rewards.
Okay. So accuracy rewards make sense.
Mm-hmm.
You get a reward for getting the right answer.
Yeah.
But how do you define correct, especially for these complex reasoning tasks?
Well, for tasks like math problems,
Yeah.
where there's a clear numerical answer,
Right.
or for like leak code programming challenges,
Mm-hmm.
where you can run the code and see if it passes the test cases.
Yeah.
It's pretty straightforward.
Right.
Either the model produces the right answer or it doesn't.
You got it or you don't.
Yeah.
What about the format rewards?
So the format reward was there to encourage the model to structure its reasoning process in a specific way.
Okay.
They wanted it to put its step-by-step thinking between these special tags.
Okay.
Think tags.
Like literally think tags.
Literally think tags.
Interesting.
And then put the final answer between answer tags.
So it's like show your work.
Yeah, exactly.
But in code.
Yeah, and they rewarded the model for doing that,
Okay.
regardless of whether the reasoning was actually correct at this stage.
So even if the model got the wrong answer, but it showed its work in the right format,
It would still get a reward.
you'd get a reward for the format.
Exactly.
Interesting. So they're really encouraging it to kind of lay out its thought process.
Yeah, and this was really important because it allowed them to actually see what the model was thinking.
Yeah. Peek into the brain.
Yeah, exactly.
Now, something they mentioned in the paper is that they specifically didn't use neural reward models at this stage.
Yeah, that's a really important point
Why is that?
because they were worried about reward hacking.
Okay.
These neural reward models,
Yeah.
they can be very powerful,
Yeah.
but they can also lead the model to find ways to maximize the reward without actually improving its reasoning.
Oh, right. So it's like gaming the system.
Exactly.
Yeah.
And they wanted to avoid that.
Keep it pure.
Yeah, they wanted to keep the training signal as clean and simple as possible
Okay.
so they could see what was really happening.
What was really going on.
Yeah.
Now, how did they actually structure the training interactions?
So they used a very simple template, which they show in Table 1 in the paper.
Okay.
It's basically a conversation between a user and an assistant.
Okay.
The user asks a question,
Yeah.
and the assistant is supposed to provide reasoning in those think tags,
Yeah.
and then the final answer in the answer tags.
So very simple,
Very simple.
straightforward.
No hand-holding.
No specific instructions on like what kind of reasoning to use or any examples of good reasoning.
No, just here's the question.
Figure it out.
Figure it out.
And that was it.
That was it.
Wow.
And the results were pretty amazing,
They were.
considering how simple the setup was.
So let's talk about the results.
Okay.
What kind of performance did this pure RL approach achieve?
Well, one of the benchmarks they used was the AIM,
Okay.
which is a pretty challenging math competition.
Yeah, for high school students, right?
Yeah, for really smart high school students.
Okay.
So it's a good test of reasoning ability.
Right.
And DeepSeek-R1
Yeah.
showed significant improvement on the AIM 2024 benchmark during training.
Okay.
It started at a pass at one score of only 15.6%
Okay.
and went all the way up to 71%.
Wow. That's a huge jump.
Yeah, it is.
And they said that puts it in the same ballpark as OpenAI's 010912 model,
Right.
which was known for being really good at reasoning.
Yeah, it was one of the best models at the time.
And they have a table in the paper, table 2,
Yeah.
comparing DeepSeek-R1 to 010912 on different benchmarks.
Mm-hmm.
So not just AIM.
Right. They also looked at Math 500, which is another math data set.
Okay.
GPQA Diamond, which is a question-answering benchmark,
Mm-hmm.
live code bench for code generation.
Yeah.
And even Codeforce's Rating, which is a competitive programming platform.
Wow.
And DeepSeek-R1 actually did better than 010912 on some of these.
No way.
Yeah, and remember, this is all without any supervised data.
That's incredible.
It's pretty amazing.
So this pure RL approach, it's like unlocking something.
Yeah, it's really exciting.
Now, the paper also talks about this self-evolution process that they saw.
Yeah,
What was
yeah.
that all about?
So as they were training DeepSeek-R1,
Yeah.
they noticed that it started generating longer and longer responses,
Okay.
which they interpret as the model taking more time to think.
So it's not just finding the answer faster.
Yep.
It's actually like developing a more elaborate thought process.
Exactly. And this wasn't something they programmed in.
No.
It just emerged naturally.
Wow. So it's like learning to think more deeply on its own.
That's the really interesting part.
And as it was generating these longer responses, did they see any like qualitative changes in the reasoning?
Yeah, they started to see more sophisticated behaviors,
Okay, like what?
like self-verification,
Okay.
where the model would go back and check its own steps,
Wow.
and also exploring different approaches to a problem.
So it's like trying different things.
Yeah, and seeing which one works best.
That's really cool.
And they actually describe this specific aha moment
Oh, tell me about that.
that they saw in one of the intermediate versions of DeepSeek-R1.
Okay.
So the model was working on this math problem,
Yeah.
and it seemed to realize that it needed to change its approach.
Okay.
And the transcript actually shows it saying, wait, wait, what?
Wait.
Yeah, like it's having this realization.
It's like a person.
I know, it's crazy.
And then it reevaluates its steps and goes down a different path.
Yeah, exactly.
So it caught itself making a mistake.
It seems like it did.
And then it went back and corrected it.
And I think that's one of the most compelling examples of the kind of reasoning behavior that can emerge from RL,
It really is.
just by giving the model these incentives to explore.
Yeah, it can figure out these really interesting strategies.
Yeah.
Now, the paper does mention some drawbacks of DeepSeek-R1,
Right.
which led to the development of DeepSeek-R1.
Mm-hmm.
So what were some of the issues with DeepSeek-R1?
Well, the main problems were readability and language mixing,
Okay.
because DeepSeek-R1 was trained purely on RL
Yeah.
without any guidance on formatting or language consistency.
Okay.
The reasoning it produced could be kind of messy,
Well,
hard to follow,
right.
and sometimes it would even switch between languages.
Oh, wow.
Yeah, in the middle of a response.
So it's a brilliant reasoner,
Yeah.
but not exactly user-friendly.
Not the best communicator.
So how did DeepSeek-R1 try to address these problems?
So they took a different approach with DeepSeek-R1.
Okay.
They called it the cold start approach.
Cold start. Okay.
And the idea was to give the model a little bit of a nudge in the right direction
Okay.
before they started doing RL.
So kind of prime the pump a little bit
Exactly.
with some good data.
Yeah.
And specifically, they used chain of thought examples for this cold start, right?
Yeah, so chain of thought is this technique
Yeah.
where the model explicitly shows its reasoning step by step.
Right. It's like writing out the steps of a math problem.
Yeah, exactly.
So you can see how it got to the answer.
Yeah, and they collected thousands of these high-quality chain of thought examples,
Okay.
and they fine-tuned the base model, DeepSeek V3 base, on this data.
Okay.
So that's the cold start.
Okay. So they're essentially giving the model a bit of a head start
Yeah, exactly.
by showing it these good examples of human reasoning.
Human-like reasoning.
Human-like reasoning before they let loose with RL. Okay, so how did they actually collect these chain of thought examples?
So they used a few different methods.
Okay.
One was few-shot prompting,
Okay.
where they give the model some examples
Yeah,
and then ask it to generate its own.
got it.
They also directly prompted models to give detailed answers
Okay.
with like reflection steps,
Okay.
where the model would kind of explain its thought process.
Right.
And then they even took some of the outputs from DeepSeek-R1
Okay.
and had human annotators clean them up.
So they were like taking that raw reasoning power and making it presentable?
Exactly.
Yeah.
Very clever.
And they also did some human annotation to make sure the quality was good.
Okay, so this cold start data
Yeah.
It had a couple of advantages they were hoping for.
Yeah.
One was readability, obviously.
Yeah.
Given the issues they had with DeepSeek-R1 0.
Mm-hmm.
What was the other advantage?
Well, they thought it might lead to better performance overall.
Okay.
Because by showing the model how humans reason,
Yeah.
it might learn more quickly.
And maybe even achieve higher levels of reasoning ability.
So they're baking in these like human priors into the data.
Yeah, exactly.
And then hoping that that'll help guide the model towards better solutions.
Mm-hmm.
And this cold start data, they had a specific format they used for it, right?
Yes.
With these special tokens.
Yeah, so the format was a special token, then the reasoning process,
Okay.
and then another special token, and then a summary.
Okay.
So they separated the detailed reasoning from a concise summary.
So it's easy to read?
Yeah, it's much easier to understand.
Okay.
And they also filtered out any responses that weren't reader-friendly.
Okay. They had high standards.
Yeah, they wanted to make sure the quality was good.
Okay, so now we've got this cold start data.
Yeah.
It's in a nice human-readable format.
Yep.
And then they moved on to the reasoning-oriented reinforcement learning phase.
Uh-huh.
So was this similar to what they did with DeepSeek-R1 0?
Yeah, they used the same GRPO algorithm, but now they were starting from the model that had been fine-tuned on the cold start data.
So it's already got a little bit of a foundation
Exactly.
in good reasoning.
Yeah.
And I think they also introduced this language consistency reward at this stage.
They did.
To address that language mixing issue that we saw with DeepSeek-R1 0.
Yeah, they calculated this reward based on the proportion of words that were in the target language.
Okay.
So if the prompt was in English,
Yeah.
they wanted the reasoning to be in English.
Okay.
And they found that this actually helped a lot with readability.
Okay, so it made the reasoning more consistent.
Yeah, even if it hurt the performance a little bit.
Right. They were willing to make that trade-off.
Yeah, because ultimately they want a model that humans can understand.
Right. It's not just about getting the right answer.
Exactly.
It's about being able to communicate that reasoning.
Yeah.
So now we've got this language consistency reward
Uh-huh.
combined with the accuracy reward.
Yeah.
And that's the overall reward signal for this RL phase.
Yeah.
Okay, so what comes after this reasoning-focused RL?
So the next step is called rejection sampling and supervised fine-tuning.
Okay, that's a mouthful.
Yeah, it's a bit of a mouthful.
I'll have to break that down.
So the idea here is that they've got this model
Okay.
that's been trained with RL
Mm-hmm.
and is pretty good at reasoning.
Okay.
But they want to improve it even further
Okay.
and also collect more data.
Okay.
So they use this technique called rejection sampling,
Okay.
where they basically have the model generate a bunch of different reasoning paths
Okay.
for a given problem,
Yeah.
and then they only keep the good ones.
So it's like the model's trying out a bunch of different ways to solve the problem,
Yeah.
and then you only keep the solutions that look really promising.
Exactly.
Okay.
And they also use a generative reward model
Okay.
to help them evaluate the reasoning paths.
So it's like another model that's judging how good the reasoning is.
Yeah, exactly.
And they did this for a bunch of different reasoning jobs. And they ended up with about 600,000 reasoning samples.
Wow, that's a lot of data.
Yeah, it's a lot of data.
Now, what about the non-reasoning data?
So for non-reasoning tasks,
Yeah.
like writing and factual QA,
Uh-huh.
they actually just reuse data from DeepSeek v3.
Oh, okay, so they're leveraging the existing data they had.
Yeah, they didn't need to collect anything new for those tasks.
Okay.
So they combined all this data together,
Yeah.
about 800,000 samples in total,
Okay.
and they fine-tuned DeepSeek v3 base on that.
So they're fine-tuning it on both reasoning data and non-reasoning data.
Exactly.
Kind of round out the model's abilities.
Yeah, they wanted to be good at everything.
Now, after this big fine-tuning step,
Mm-hmm.
they did another round of RL right.
They did.
They called it RL for all scenario.
Yeah.
So how did this differ from the first RL phase?
Well, in this phase, they used a wider range of reward signals
Okay.
and prompt distributions.
Okay.
So for the reasoning data, they still use those rule-based rewards,
Okay.
like accuracy and language consistency.
Yeah. But for the general data, they used reward models
Okay.
to evaluate things like helpfulness and harmlessness.
So making sure the model is safe and aligned with human values.
Yeah, exactly.
And they also use the DeepSeek v3 pipeline to generate preference pairs, which I guess is another way of getting feedback on the model's responses.
Yeah, it's like asking humans which response is better.
Okay, so they're really trying to get a lot of different feedback signals into this final RL phase.
Yeah, they're trying to fine-tune the model as much as possible.
So after all this training, How well did DeepSeek-R1 actually perform?
It did really well.
Oh,
They
yeah.
compared it to a bunch of other models on a variety of benchmarks.
Yeah, I was looking at Table 4 in the paper. It's
Yeah.
pretty extensive.
It is.
So what were some of the highlights?
Well, on the AME 2024 benchmark,
Yeah.
DeepSeek-R1 actually did slightly better than OpenAI's O1-1217 model.
Wow, that's impressive.
Yeah, O1-1217 was a really strong model.
Yeah.
And DeepSeek-R1 also did really well on the Math 500 benchmark. And it got an expert level rating on code forces.
So it can write really good code.
Yeah.
And what about other areas beyond math and code?
It also did well on knowledge benchmarks like MMLU and GPQA Diamond.
Okay.
And it showed strong performance on long context understanding and instruction following.
So it's a pretty well-rounded model.
Yeah, it is.
Now, they did mention a slight dip in performance on the Chinese Simple QA benchmark.
Yeah, that was because of the safety RL they added.
Right.
They said that without the safety measures, the model could have gotten over 70% accuracy.
So it's a trade-off between safety and performance.
Yeah, which is always a tough balance.
But I guess that's the responsible thing to do.
Yeah, you don't want to release a model that's going to say harmful things.
Absolutely.
Yeah.
Now, the paper also explored this idea of distillation.
Right.
So what was that all about?
So distillation is this technique where you take a large model
Okay.
and you try to transfer its knowledge to a smaller model.
Oh.
And the goal here was to see if they could transfer the reasoning capabilities of DeepSeek-R1
Yeah.
to smaller models in the Quinn and Llama series.
Okay. So making it more accessible.
Exactly, because these smaller models,
Yeah.
they're much cheaper to run
Right.
and easier to deploy.
Makes sense.
So how do they do this distillation?
Yeah.
Well, they took that 800,000 sample data set that they curated for DeepSeek-R1,
Yeah.
and they just fine-tuned the smaller models on that.
So it's like teaching the smaller models by showing them the answers that the big model came up with.
Yeah, exactly.
Okay.
And the results were pretty impressive.
What did they see?
So they found that the 7B-QN model that they distilled
Okay.
actually outperformed some non-reasoning models like GPT-4o.
Wow. So even a relatively small model can get really good at reasoning.
Yeah, with the right training data.
And the 14B model was even better?
Yeah, it beat the state-of-the-art open source model at the time.
Okay.
And the 32B and 70B models were even better than that.
So it seems like the bigger the model, the better the performance.
Yeah, but even the smaller models were pretty good.
Which is really encouraging.
It is.
Now, they also compared distillation to directly training a smaller model with RL.
Right.
What did they find there?
So they took a 32B Quinn model
Okay.
and they trained it with RL, just
Yeah.
like they did with DeepSeek-R10.
Okay.
And they found that it wasn't as good as the distilled model.
Really?
Yeah, it got about the same performance as the state-of-the-art open source model,
Okay.
but it was significantly worse than the distilled model.
So distillation seems to be the way to go.
Yeah, for smaller models at least.
For smaller models.
If you want to get really good performance,
If you want the best performance, you need a bigger model.
yeah, you still need a big model to train the smaller model.
But it's nice to know that you can transfer that knowledge
Yeah,
down to something that's more manageable.
exactly.
Now, the paper also mentions some unsuccessful attempts they made during the development of DeepSeek-R1.
Yeah, they talk about a couple of things that didn't work out so well.
And I think it's valuable to hear about those.
Yeah, I think it's important to talk about the failures too.
Because you learn just as much from things that don't work as you do from things that do work.
So one of the things they tried was using a process reward model,
Okay.
or PRM.
PRM.
And the idea behind a PRM
Yeah.
is to reward the individual steps in the reasoning process.
Okay.
So not just the final answer,
Right.
but each step along the way.
Makes sense.
But they ran into a few problems.
Okay, like what?
Well, it was hard to define what the steps should be
Okay.
for a general reasoning task.
Right.
And it was also hard to determine whether a step was actually correct.
Okay.
Because you can't always just run a test case
Right.
like you can with code,
Yeah.
and manual annotation doesn't scale.
No.
So in the end, they found that the benefits of PRM didn't really outweigh the costs.
Okay. So interesting idea.
Yeah.
But hard to implement effectively. Okay. What was the other thing they tried?